Hi guys, so in this video we are now discussing all about isentropic process. So isentropic process is very useful to understand with different cycles such an internal combustion engine and a Rankine cycle and gas turbine or etc. So these all topics that I mentioned is we have to discuss it later in this next chapter. So, isentropic process is the system which are thermally insulated from their surroundings, undergo process without any heat transfer, such as process called adiabatic. So, an isentropic process is a reversible adiabatic process. Adiabatic simply means no heat, or a reversible adiabatic is one of constant entropy. So, an isentropic process is a thermodynamic process in which the entropy of the fluid or gas remains constant. It means the isentropic process is a special case of an adiabatic process in which there is no transfer of heat or matter. And then it is a reversible adiabatic process. So reversible means it means that your your gas or some fluid is kanang more return into initial state. Okay, so an isentropic process can also be called a constant entropy process. In engineering, such an ideal process is very useful for comparison with real process. So if we describe this process, this isentropic process, we can describe it from a PV diagram. So let us to describe this process. So PV diagram. So from 1 and 2, and this is a typical figure of the isentropic process. So the isentropic process or a special case of adiabatic process can be expressed as PV raised to K is equals to constant. Ayan. And then the the it has a little bit different uh, from the uh, isothermal process. So PB is equals to C. In the area under the curve of this isentropic process is the value of the non-flow work, which is the integration of PdV. And if we get or if we describe the figure of isentropic processes from this diagram, so yan. So since that the entropy is constant, so mo na yung figure from 1 to 2. Okay? So in relation between P and B, since B raised to K is equals to constant, so the form of this equation is held to P1 V1 raised to K is equals to P2 V2 raised to K. And then the relation between P and V, so from P1 V1 raised to K and P2 V2 raised to K, and the combined equation law, we have this P1 V1 over T1 is equals to P2 V2 over T2. So we can get the equation relation between T and V from this all this equation that we've been discussed. So T2 over T2 we rewrite into this P2 over P1 is equals to B1 raised to K over B2 raised to K. So gi kuan na nato gi cross multiply or divide both sides, and T2 over T1 from here, T2 over T1, then kani, i-divide. So, ma-rewrite siya into form P2 V2 over P1 V1. And then, we can say that our P2 over P1 is equals to V1 raised to K over V2 raised to K. So, we can substitute this equation. So, if we write this form, so we can say that T2 over T1 is equals to V1 raised to K V2 over V2 raised to K times V1. And then, we uh, we transpose this to kaning B1 into numerator and then B2 into denominator. So we can say that your B1 is mag negative 1 and then also your B2 raised to negative 1. So if we sani, if we came, so if we came up this B1 times B1 raised to K times B1 times negative 1, and it will become a B1 raised to K minus 1. Then, ano siya? So, T2 over T1 is equals to B1 over B2 raised to K minus 1. Okay? So, in relation between T and P, so, from the value of from this equation, P1 B1 raised to K and P2 B2 raised to K, so we can say that T2 over T1 from this equation, so ato i-substitute ang kaning B1 over B2, so mahimo siya og P2 raised to negative K over P1 raised to negative K. And then, ipagawas ni siya, so mahimo siya og ing-ani nga form. So, T2 over T1 is equals to P2 over P1 raised to K minus 1 over K. So, for non-flow work, so we have, since we have PV raised to K is equals to constant, or P, or we can say, or we can rewrite P is equals to C raised to V negative K. So, ato lang gi-divide, no? Ang kaning V raised to K. So, ato lang gi-transpose pa dong dito sa PCAS equation. So, since the work non-flow is equals to integration from process 2 to 1 PdV. So, since that P is equals to CV raised to negative K, so ato ma-substitute ang kaninga equation from this equation. So, may mo siya og C times B raised to negative K times dV. And then, the work none, if we integrate this, so, kung mag-integration ta, property sa kuan, power rule, we have negative, mag-raise to 1 ta or rises from 1. So, negative K plus 1 over negative K plus 1 from 2 to 1. So, our value of C, so from this equation, so we have C equals to PV raised to K. So, PV raised to K. And then, if we simplify this equation, so may mo na siya og V raised to 2 negative K plus 1 over negative K plus 1, or we can say, so from this equation, ano siya, from upper minus lower limit, so mahimo na siya ging ani nga equation. So from P2 B2 minus P1 B1 over 1 minus K. And for the change of internal energy, so we can say that the change of U is equals to MCV times T2 minus T1. For the heat transfer, since the definition of isentropic process is an adiabatic, which means there is no heat transfer or mass mass transfer. So our Q or heat is equivalent to zero from our system. And then the change of enthalpy, we have MCP T2 minus T1, or temperature 2 minus temperature 1. So for the change of entropy, since uh, since this definition of isentropic process is also a constant entropy, so the change of entropy is equivalent to zero. And for the steady flow isentropic, we have this equation from the first law of thermodynamics. So we can create this equation. So Q is equals to change of P plus change of K plus change of H plus work steady flow. Since our Q is zero, so we can cancel out. So assume that your change of potential energy is equals to zero and your change of kinetic energy is equals to zero. So we can rewrite into form work steady flow is equals to negative change of enthalpy. And for the B, we have negative, or the work steady flow, we have this negative change of integration of VdP is equals to work steady flow plus change of K. Since let's C is equals to P raised to 1 over K, V, or V is equals to P raised to 1 over K, C na. So you can say that your uh, negative integration of VdP, so we can rewrite into form integration of P raised to 1 over K C dP. So integrating and simplifying, so we can came up this equation, that is K P2 V2 minus P1 V1 over K minus 1. Or we can simply say that your steady flow work is equivalent to K times the non-flow work, or K integration of PdV. So let us have an example. So sample problem number 1. So from the state defined by 300 SIA and then 100 cubic feet and 240 degrees Fahrenheit helium undergoes in isentropic process to 0.3 psij, or pounds per inches squared gauge. So first find volume 2 and the temperature 2. And then secondly is change of internal energy and change of enthalpy. And the C is find the non-flow work. And the D is find the steady flow work. And the E is the heat. And the change of S, or change of entropy. So what is the work? So for the F, if the process is non-flow, and for the G, if the process is steady flow with change of K is equals to 10 BTU, or British Thermal Unit. So for the solution for this problem, so sa A sa ta, so we have P1 B1 raised to K na relation between P and B equals to P2 B2 raised to K. So if we substitute the given problem, we have 300 psia and then 100 cubic feet. So for the K, so it means a specific uh, heat ratio. So this K or equivalent to K is equals to Cp over Cv. So for the helium, so the helium is ng so the value of the monatomic or on a single atom, so the specific heat ratio ana is equivalent to 1.67. For the diatomic, so the value of the specific heat ratio is equivalent to 1.4. So raised to 1.67 is is equals to 0.3 since it is a gauge pressure, so we have to convert into absolute pressure. So we have 0.3 plus 14.7 psi times B2. So may gipangita, gidetermine sa problem. We have B2 raised to 1.67 B2 or the volume 2. So if we calculate this, so we can get the value of volume 2. So the volume 2 is equivalent to 601.26 feet squared. So ato i-recheck. We have 300 times 100 raised to 1.67 is equals to 0.3 plus 14.7 times alpha x or the unknown value. We have 1.67. Then shift solve equals. So we have this value 600.26 feet. No, it is a feet cube raised to 3. So nasayop lang. So for determining the temperature 2, we have this equation. So T2 over T1 is equals to V1 over V2 all over raised to K minus 1. So we have T2 over the given problem, we have 240 degrees Fahrenheit is equals to 100 over 601, or the 100 is the volume 1 or 100 cubic feet. And then sa atong nakuha ganiha, we have volume 2 601.26 feet cube raised to K minus 1, which is ang K is 1.67 minus 1. Then we can get the value or temperature 2 is equivalent to 201 degrees Rankine, or T2 is equals to negative 250 degrees Fahrenheit. So if we perform again, if we perform this equation, so dapat i-absolute nato ang tanang value. So absolute temperature, absolute pressure, so kana. In B, so in B is for the change of U and change of H. So since wa pa man tay mass, so we can use the ideal gas equation of state. We have P1V1 is equals to M or mass times the gas constant times the temperature 1. So since we have the value of pressure 1 and then the value of volume 1 and then the gas constant, so ma-determine ra nato no for the general gas constant nga equation and then the temperature 1. So dapat i-absolute ni sila. So from 300 times 100, 300, sakto ba? Wait lang. So 300 psi. So kani siya, which mean ang helium nato is kuan man, pila na siya. The molecular weight for the helium is 4 man. 4. So we can get the value of the gas constant. So dapat na ni siya times 144 no for converting the inches squared into feet squared para mabalance ang atoang equation. So nasayo pra ni siya. We have 300 times 144 times the 100 cubic feet times alpha equals times the equals to unknown value or the mass, then the 386.04 times the absolute temperature 700. Shift solve equals, so we can get the value of the mass. We have 15.97 or approximately 15.99. So for change of internal energy, we have MCB T2 minus T1 nga formula. Since we have the mass naman, so we can say that 15.99. So for the formula of constant volume, specific heat constant volume, we have R over K minus 1. So R, we have 386.04. And for the K, we have 1.67. Then minus 1. And then the temperature to 210 minus 700. So we can get the value for change of internal energy in terms of feet LB. But in terms of BTU, we have the conversion for this. So in 1 BTU, we have 778 feet LB. Then we can get the value in terms of BTU. We have negative 5082.6 BTU. And for the change of enthalpy, we have MCP change of T or T2 minus T1. So the change of H is equivalent to mass. We have mass 15.99 and the formula for uh, specific heat constant pressure, we have RK over K minus 1. So R is equivalent to 386.04 and K is 1.67. So 386.04 times 1.67 over 1.67 minus 1. And then the temperature 2, we have 210 and 700 for temperature 1. So we can get the value of change of internal energy in terms of feet LB. So by conversion for BTU is equivalent to 778 feet LB. So we can get the value of BTU. We have negative 9690.34 BTU. So sa C, for the non-flow work, we have this formula. P2B2 minus P1B1 over 1 minus K. So, ato lang i-substitute ang mga nakuha nga given and nasad sa given problem, we have 15 times 601.26 times 144 minus the 300 for the pressure times 100 for the volume times 144. Ato i-convert para in terms of feet LB minus 1 minus 1.67 and i-convert na to in terms of BTU, we have 778 over 778. So we can get the value for non-flow work. So we have 5796.11 BTU. So since naka-conclude naman ta nga ang ato ang steady flow work is times ra og K sa non-flow work. So or K is times for integration of PdB. So since we have the value of non-flow work, so we have 5796.11 BTU. So i-times na lang nato into 1.67 or the specific heat ratio niya. So makuha gyapon nato ang yang steady flow work. So the value of the steady flow work is 9679.50 BTU. So for so Q, since our process is isentropic, so it means no heat transfer. So the Q is equivalent to 0. And also for the change of entropy. So change of entropy is for the isentropic, the definition of isentropic, we have constant entropy. So the change of S is equivalent to 0. So for this, uh, F, if the process is non-flow and then if the process is steady flow, so G with change of key. Na siya ay given sa change of internal energy which is 10 BTU. So go back to our solution. Kani. So for by applying the first law of thermodynamics, so we have negative VdP is equals to work steady flow plus change of K. Since we have the value of uh, this, we have 9679.50 BTU. There is a data. So we have Q is equals to change of U plus work none. So work none is equals to negative change of U since ang Q nato is equivalent to 0 man. So atong work none is negative change of U or the work none flow nato is equals to negative 5082.6 BTU. So nakuha nato nga change of internal energy nato earlier. So for this, negative integration of BDP is equals to work steady flow plus the change of K. So natay given nga change of kinetic energy which is 10 BTU. So we can get the value of work steady flow. So we have negative BDP is equivalent to 9679.50 BTU is equals to work steady flow plus 10, or the equivalent for work steady flow is equals to 9669.50. So that's all for now, and thank you and have a good day.